Hi everyone, I am Pranav and today's presentation is about first order RL circuits. Now we'll discuss some basic concepts of RL circuits and also solve some problems related to it. Introduction to first order RL circuits. Circuit composition. First order RL circuit consists of a resistor and an inductor connected in series. Time dependent behavior. The current and voltage in a series RL circuit, it depends with time exponentially, and it also has separate formulas based on the charging and discharging of the circuit. Applications. RL circuits are also having some day-to-day life applications, such as they are used in power supplies, motor control and filter design, etc. Characteristics of first order RL circuits. Time constant. It is one of the most important characteristic of first order RL circuit. Before solving any problem, we just find out the time constant of the circuit and then proceed further. It is given by the formula L by R, where L is the inductance of the circuit and R is the resistance of the circuit, and which determines the circuit's rate of response to changes. Exponential behavior. As said earlier, voltage and currents in RL circuits, they exhibit exponential rise or decay over time. Energy storage. The inductor stores the energy in the form of magnetic field, and it is given by the formula half Li square, where L is the inductance of the circuit and I is the value of current flowing through the inductor. Step response of a first order RL circuit. It tells about the variation of current with respect to time. Initial response. When a step input is applied or when the voltage is initially applied, the current initially rises rapidly, limited only to the resistor. Exponential decay. As the time passes, the current exponentially approaches its steady state value as the inductor's magnetic field builds up. Time constant. Time constant is defined as the time in which the current or voltage reaches to 36.8% of its initial value, or the time in which it reaches 63.2% of its final value. Now let's discuss some problems based on RL circuits. Example 1. The first type of problem is charging of an inductor in an RL circuit. Question. A series RL circuit has a resistance R equal to 10 ohms and inductance L equal to 5 Henry, and a voltage V is equal to 20 volt is connected to the circuit at time t equal to 0. Determine the time constant of the circuit and the current I of t at time t equal to 0.5 seconds. Time constant. It is given by the formula L by R, which is equal to 5 by 10, which is equal to 0.5 seconds. Current as a function of time. The formula of current in the charging of an RL circuit is given by the formula I of t is equal to I max into 1 minus e raised to minus t by tau. Now finding out the I max by the formula V by R, we get 20 by 10, which is equal to 2 amperes. Now substituting the time t equal to 0.5 seconds in this formula, we get I into 0.5 is equal to 2 into 1 minus e raised to minus 0.5 upon 0.5, which is equal to 2 into 1 minus e raised to minus 1. Using the approximation, e raised to minus 1 is equal to 0.3679, which is equal to 2 into 1 minus 0.3679, which is equal to 2 into 0.6321, which is 1.264 amperes. Now let's move to the another type of problem, which is discharging of an RL circuit. In an RL circuit, the inductor initially carries a current of I equal to 3 amperes, the resistance of 20 ohms, and inductance of 4 Henry. The current is disconnected from the power source at time t equal to 0. Here we can notice that the current is disconnected from the power at time t equal to 0. From this we can easily identify this is a discharging of an RL circuit problem. Now we need to find the time constant tau and the current at time t equal to 1 second. Time constant. Tau is equal to L by R, which is 4 by 20, which is equal to 0.2 seconds. Current during discharge. The relation of current and time during a discharging of an RL circuit is given by the formula I of t is equal to I into e raised to minus t by tau. Substituting the value of time 1 second in the formula, we get I into 1 is equal to 3 into e raised to minus 1 upon 0.2, which is 3 into e raised to minus 5. Using the value e raised to minus 5 is 0.0067, that is equal to 3 into 0.0067, which is equal to 0.201 ampere. Let's move to another type of problem, which is voltage across the inductor problem. A series RL circuit with resistance 8 ohms and inductance 2 Henry is connected to a 24 volt source at time t equal to 0. Find the voltage across the inductor at time t equal to 0.25 seconds. First, time constant. Tau is equal to L by R, which is 2 by 8, which is 0.25 seconds. Voltage across the inductor. The variation of voltage with time in the RL circuit is given by the formula V of t is equal to V max into e raised to minus t by tau, which is similar to the value of current in the discharging of RL circuit. Now substituting the value of time 0.25 seconds in the above formula, we get V of 0.25 is equal to 24 into e raised to minus 0.25 upon 0.25, which is 24 into e raised to minus 1. E raised to minus 1 approximately is equal to 0.3679. That is equal to 24 into 0.3679. We get 8.8296 volt. I hope that all the problems are clear to you. Now, conclusion and key takeaways. Circuit behavior. First order RL circuits exhibit exponential rise or decay and time constant characteristics. Design considerations. The time constant tau is equal to L by R is crucial in determining a circuit's transient response. Applications. As already said earlier, RL circuits are also having some day-to-day life applications, such as they are used in power supplies, motor controls, and so on. Thank you.